So we then come to perhaps the most widely used test of change of direction in the world. Originally proposed by Cureton back in 1951. It's been amended since then a little bit, because in the original format the participant would actually start in the prone position, they'd be asked to jump up and then go into the test. That's subsequently been moved, or removed, sorry, and now it's very much just about starting on your feet. So start in the prone position, and then we've moved to the standing start. So generally assessed over 2 trials. Now that is quite interesting, because generally if I'm trying to take a mean of something, I would probably, because I'm trying to be reliable, do it over at least 3. Think about it. If I'm doing it over 2 trials and I've got one where I don't run very fast and one where I run really fast, then actually the mean is kind of biased by those results. Or I've got one where I'm really slow and one when I'm okay. It's biased by the really slow score. So this is why we tend to do it over 3, not 2. So you might want to ask yourself, why is it only over 2 trials? Now, there's a large number of groups who have reported that this is a reliable test using what are called interclass correlations. Now, ICCs are recognised as being a valid method of assessing reliability. They are not the same as a Spearman's or Pearson's based correlation. They're a different way of looking at this. And in fact, I've got it here, for example, in rugby league players. But there are similar outcomes when when studies have looked at this in basketball players, netballers, and so on and so forth. But now you have to ask yourself 2 things. One, is it applicable to all sports? And is it applicable to all individuals? So clearly, there are certain groups of individuals this may not be applicable to. So perhaps, for example, people who've got lower limb issues. But also, does it relate to all sports? And I'll explain that as we go through it. And then we may need to think a little bit about the kind of the agility of change of direction. But again, very much as with the zigzag test, the one thing we know is there is no spatial uncertainty. We know what the course looks like. So the only thing that we've got is temporal uncertainty. So here's the course. And this might give you an understanding about why the question was asked, about why is this relevant for all sports. So what you can see is that you start on the right hand side, and automatically your brain should be telling you that a lot of the issues that we pinpointed with the zigzag test apply here. Because you're going to sprint 9.15 meters, then turn, then sprint back another 9.15 meters, turn, come through cone 1, then cone 2, then cone 3, then turn around cone 4, come back through the track, so 3, 2 and 1, then sprint another 9.15 meters and turn at the top left, and then sprint back to the finish line. So what you would have is a light gate at the start and a timing gate at the end. But think about that very logically. You're sprinting 9, let's call it 9 meters from the start to turn 1, then another at least 9 meters from the turn 1 to the first cone, so we're at 18 meters. Then we're going to sprint, using our turns, another 9 meters, so now at 27. Then I'm going to sprint back another 9 meters, I'm at 36. Then I'm going to sprint another 9 meters, which takes me to 45. And then I'm going to sprint another 9 meters, which takes me to 54 meters of sprinting. Same issue arises. How do you know in this test whether your participant is good at change of direction, which in essence is only being covered through those turns really in the middle? There's a couple of turns at the end of each of the end of the start straight and at the start of the finish straight. But how do you separate those out? How do you separate out what is sprint speed from what is change of directional speed? So what you'll end up with is somebody that might complete this in, say, 17, 16 seconds, for example. Great. But how much of that actually is about straight line speed, and how much of that is about change of directional speed? And that is fundamentally at the heart of this in terms of the limitations with what you're referring to here. Yes, it fits with some of the some of the things that are in that schematic. There is a left and right side, but you cannot separate out left and right imbalances, because all you get is basically a time to complete the test. So you don't know whether somebody's better turning to the left or turning to the right, which fundamentally, as an S&C coach and a physiologist and a therapist, you would want to know. Because that is really important, isn't it? It's important in terms of treatment. Is there a left and right balance? It's important in terms of training. Is there a left and right imbalance? It's important in terms of assessment. Is there a left and right imbalance? You can't separate those out. You can't separate out the change of direction from the sprint speed. So it's, in many ways, if you think about what you're looking at here, the validity is low. So the reliability, yes, it may well be high. You may well be able to get somebody to repeat the test twice and get a very, very similar time. But just being reliable doesn't mean it's applicable. And so, yeah, great, test retest, but how valid is this as a measure of change of direction? And you would argue that it is not a valid measure. So let's look at this in action. So let's have a watch of somebody doing this. So you can see here we've got the light gates set up, and you'll see what I was referring to in terms of the amount of time this takes.
Oh, wow, yeah.
So you could see that quite clearly. So let's just watch that again from the beginning. Now what I want you to focus on now is how much of this is about change of direction. There's one change of direction. There's two. But the middle, look, he's barely changing direction. The third change of direction there. But you can almost run straight. Fourth change of direction there. Fifth change of direction there, straight line. So how do you separate out the change of direction from the sprint speed? You have no way of doing that, and yet the one thing we're after is the actual change of direction of the athlete. So we've got some data here which is about the kind of the reliability of this, and we're not going to dispute the reliability. There's absolutely no point in disputing that, but it's quite nice to show you this. So what you can see here is in the top panel, what they've done is they've got a test 1 and a test 2, so that's test retest. So 16.30 plus or minus 0.7 seconds, which is as a group score, and the retest was 16.23 plus or minus 0.83. The interclass correlation that you can see here has got a correlation of 0.96, that's an ICC, and it's got confidence interval of 0.85 to 0.98. So the range in terms of the variability, that's what the confidence interval shows us, is actually quite small. Okay, so the range there is, if I do my basic maths, it's about a range of about 0.13. So it's fairly small. If we look at the panel below, this is the limits of agreement. So the limits of agreement is calculated, we've referred to this in previous sessions and I'll show you again in this one, but it's calculated as the mean of the differences, which is our bias score. So they will take, for each participant, they'll work out the difference between test 1 and test 2. They've worked out the mean of the differences. The mean of the differences is 0.07 seconds. And then what you have is the 95% confidence intervals, which is 0.55. So what they're saying is that it will go from a bias of 0.07 and it will go up to about 0. So we go up to 0.62. And it will go down to about 0.72. So you've got a very, very small range. There's very, very little variability. So reliability is very, very good. But it doesn't get around the fact that we've already identified that validity is low. You cannot identify the agility of your athlete in this test. So yes, highly reliable, but not valid. And in fact, the authors go on to write this, which is really nice. They go on to write, look, in summary, the change of direction Illinois agility test is a reliable test for assessing speed, change of direction in male team sports players. Its performance is independent of acceleration and power of the legs, but significantly related to speed. In other words, speed is playing a massive part here. And clearly you can see that there's 54 metres, give or take, of sprint speed. So the validity of this is now being is challenged, because if speed is isn't playing an enormous part, how much of this is about the speed of the athlete, or how much is it about the change of directional speed?